Hello students, in this class I will explain the image formation by spherical mirrors which are concave and convex. So in our previous classes we know the four rules. We have four rules. Okay, four rules to draw ray diagrams. So by applying these rules here we will draw the different position of images according to their different object distance or position. Okay, so first is concave mirror. At first the object position is at infinity. The object is at infinity means very far away from the mirror. Okay, the distance between the mirror and the object is very large. It is far away from the mirror. That means at infinity. When we consider an object at infinity, we have to consider it as large. Okay, we have to consider it as large object. So here for our drawing purpose we are considering the object AB which is very large. Now two rays from this object 1 and 2 okay is incident on the concave mirror. So after reflection it will passes through a point which is in front of the mirror, that is the focus of the mirror. Okay, here this intersection point of these two rays after reflection will form a image which is real because they are intersecting in front of the mirror. Okay, and which is real intersection in front of the mirror and real intersection. And also the size, if you look at the size of this image then you will find that it is point size. It is a point size image. Okay, that means very small, so it is called highly diminished. Okay, the highly diminished image. And also when we consider the real image with respect to the concave mirror, it is always inverted, means in downward direction. That means if it is AB then the image is A dash B dash. Okay, the top will come here bottom and the bottom will come here. Okay, so it is a real image. Real image, the nature is real image and inverted because it is directed in downward direction. Though we cannot see this point size image, we have to consider it as inverted. Okay, next, now the position of the object is beyond C, means beyond C which is center of curvature and infinity. That means the object is now between the infinity and the center of curvature. Now again if we consider two rays 1, 2, according to the rule we know that when a ray parallel to the principal axis is incident on the concave mirror, after reflection it will passes through the focus. Okay, and again the second ray it's passing through the center of curvature, after reflection it will go back in the same direction. Okay, according to the rules for ray diagrams. So here this is the point of interaction of these two rays. Now if we draw a perpendicular from the principal axis to this intersecting point, then we will get the image. Okay, which is A dash and B dash. Now if you look at the image, it is diminished. Diminished means it becomes smaller as compared to the height of the object. Okay, if you look at the sizes, it is diminished. Okay, and also it is inverted, means it is in downward direction. It is inverted. Okay, so this is the characteristic of the image when the object is beyond center of curvature. Okay, next, here now the object is at center of curvature, which is C. AB is the object which is at the center of curvature. Now again, if we consider two rays, then we will see that 1 2, one ray which is parallel to the principal axis, after reflecting it will passes through a point which is focus. Now another ray which is passes through the focus and incident on this reflecting surface, after reflection it will become parallel. Okay, so if you look at the intersecting point here, then you will see that the sizes of the object and image is equal, means AB is equal to A dash and B dash. Okay, their sizes are equal, and also it is inverted, means it is in downward direction. Real and inverted, and also equal size. Remember this. Next one, now the object is in between center of curvature and focus. Okay, the object is here in between center of curvature and focus, this one. Now from this AB object, if we consider again two rays 1 and 2, you will see that one ray which is parallel to the principal axis, after reflection it passes through the focus, and another ray after reflection it will come back in the same path and passes through the center of curvature. Okay, so this is the point where they intersect, which is A dash. So if you draw a normal from the principal axis to this intersecting point, then you will get a image which is inverted, means downward direction, and also real. Real because they are forming in front of the mirror because of the real intersection of the two rays. And if you look at the size of this AB is smaller as compared to this size of this image A dash B dash. That means now the image is enlarged. Image is enlarged. Okay, next one, if you consider the object at focus. Okay, from this focus, if you consider two rays again 1 and 2, then we will see that one ray which is parallel to the principal axis, after reflection it will passes through a point which is focus. Okay, and another ray which is passing through the center of curvature, after reflection it is coming in the same path. Okay, it is bouncing back in the same path. Here in this diagram we cannot see the point of interaction, but in the infinity they will intersect with each other. In the infinity they will intersect with each other. Okay, we have to consider it that the infinity, the two rays will intersect to form an image. Okay, to form an image which is highly enlarged. As I told you that when you consider infinity, you have to consider it very large or highly enlarged. Highly enlarged. Okay, Now the image is highly enlarged, and also it is real because it is forming in front of the mirror and also inverted, okay, in downward direction. It is directed in downward direction. Okay. Next one. Now when we put the object between focus and the pole, now it is a little bit different because now it is a virtual image. Okay. Now look at the first ray 1 and 2. Here first ray is directly incident on the pole and reflecting back, okay, by making angle I incident angle and R reflecting angle with the principal axis. And the second ray, which is reflecting and bouncing back in the direction of focus, okay. Now you can see that they are diverging, okay, they are going away from each other, is not it? So it is not possible that they will meet at infinity, okay. Here, so if we increase the this rays behind the mirror, here in this direction behind the mirror, then we will see that they will intersect at a point, okay, they will intersect at a point which is lying behind the mirror, and from this intersecting point to this principal axis, if we join this with a perpendicular line, then we will get the image. Now this image is forming because of the virtual interaction of two imaginary rays, okay, virtual interaction of two imaginary rays. That's why it is virtual image, and also it is in upward direction, okay, direction of this image in upward, okay. That's why it is a called erect. Erect because it is in upward direction, okay. And also if you look at the size is enlarged, okay, size is enlarged means bigger as compared to the object, okay. AB is less as compared to the A dash B dash. So these are the characteristic of image formed by concave mirror. Now next one is convex mirror. So for convex mirror, similar to the concave mirror, if we consider a object at infinity which is very large, okay, then from this object, if we consider two rays which is parallel to the principal axis, after reflection it will diverging away, it is diverging away, yes, it is diverging away. So as I told you that there is no possibility that they will meet at infinity because they are diverging. So if we increase the rays behind the mirror like this, then we will see that it is meeting in a point in the principal axis which is the focus, okay, which is the focus of convex mirror, okay. So here again it is a point size image, and also because it is forming behind the mirror, it is a virtual point size, and it is erect, okay. Though we cannot see it is a erect or inverted because it's a point size, but we have to consider it as a erect which is directed in upward direction, okay. Next one is a convex mirror when the object is between the infinity and the pole. I already told you that no matter where you place an object in a convex mirror, it will always form virtual image, okay. So here if you put the object beyond the pole and the infinity, then you will see that if you consider the ray number 1, if you consider this one ray number 1, according to the rule after reflection it will diverges, and if you increase the this ray in the backward direction of the mirror, then it will meet in a point. Then again, if you consider ray number 2, okay, which is directed to the towards the focus, then after reflection it will parallel to the principal axis, it will become parallel to the principal axis. And again, if we consider the ray number 3, which is directed to the center of curvature, then you will see that it is going back in the same path. Okay, so here the ray number, any two rays, if you consider ray number 1 and ray number 2, then you will see that there is an intersection point here, or ray number 3 and ray number 2, there is an intersection point here which is behind the mirror. And also if you look at the size of the this image, it is diminished. Okay, means it is smaller as compared to the object, and also it is erect because it is in upward direction, and also it is virtual because it is forming because of the virtual interaction of the points. Okay, so here we understood that how the image can form in concave and convex mirror. Okay, these ray diagrams are very important. So thank you.